Alright then. Are there any more questions out there I can answer? Ah, you over there. What's your question? Is time travel possible? What a great question. And no, it's certainly not a stupid thing to ask. The short answer is yes, but the long answer is quite a bit more complicated. Allow me to explain. The first thing you need to know is the difference between time travel forward in time and time travel backward in time. Often in pop culture, a single time machine is shown to be capable of these two acts as if they are carried out under the same conditions, like a car can go forward and in reverse. In reality, these two actions are entirely separate in their own scientific rights. Let's begin with the easier one. Time travel to the future. What if I told you that time travel to the future is not only 100% possible, but that it's already been done? What? Don't believe me? Let me explain. Time travel to the future is possible, thanks to a fundamental property of our universe known as special relativity. Does anyone know what special relativity is? Yes, you there. That's right. Special relativity refers to how objects moving at different speeds experience the passage of time at different rates. This is due to the fact that the speed of light is constant in our universe. It can never be slowed or quickened, and certainly not surpassed. This is a property unique to light, as all other objects moving at any other speeds are subject to relativity. If I'm standing still and I observe a car drive past me at 60 miles per hour, I observe its speed as 60 miles per hour. However, if I'm in another car going 30 miles per hour that is surpassed by that car, I would observe it going only 30 miles per hour relative to my 30. Still, me in the car, me standing outside, and even me, if I was sitting in the 60 miles per hour car, would all observe light travelling at the same exact speed. Indeed, even if I was travelling in a car going 1 mile an hour shy of the speed of light, still nothing would change. This phenomenon can only be made possible through time dilation. Because we all observe light moving at the same velocity, some other part of the equation, velocity equals distance over time, must be altered in order to compensate. In the case of time dilation, in order to keep the speed of light constant, time slows as an object approaches the speed of light. With this in mind, we would need to take a shortcut to the future as a way to go extremely fast, say a rocket for example. Say this rocket can travel at 99% of the speed of light. If you travel at 99% of the speed of light for say 100 years, a person not on the rocket would experience 100 years passing, but you on the rocket would only experience about 14 years worth of time. Make no mistake, it wouldn't feel like time is passing in slower on the rocket. The dilation would be imperceptible, but a stationary observer watching you on the rocket from outside would see you moving in slow motion. Now, about me saying that it's already been done. Well, thanks to special relativity, it's happening all around you. Remember that you're not completely stationary right now. You stand on Earth, and Earth is spinning. Therefore, your feet are moving ever so slightly faster than your head. So, yes, in a sense, your feet are time travellers relative to your head. Just like the people in airplanes going 600 miles an hour right now are time travellers relative to us who are going 0. Fascinating, isn't it? Now, on to time travel to the past. The main reason that it is at least theoretically impossible is because of the nature of causality. This can be explained in the form of a paradox. Let's say you travel back in time to visit your parents before they meet. But, like in Back to the Future, some twist of events caused by you leads to them never meeting, which leads to you never being born. In this case, you would never be born to go on time travel back to their time in the first place, and therefore the event never even happened at all. This completely ignores the fact that an actual method of backward time travel, at least a non-theoretically one, doesn't actually exist. If such a method existed, it would have to have something to do with the manipulation of the dimension of time itself. For example, past the event horizon of a black hole, the dimensions of time and space seem to switch places as the fabric of the universe is so warped. In this way, travelling back in time would be as easy as walking backward after walking forward. But good luck getting out of the black hole after you've done that. And that of course leaves out even more wildly theoretical examples like taking shortcuts through higher dimensions. We simply don't know the endless possibilities. All we can say for certain is that while it seems impossible, we have not discovered a fundamental law preventing backward time travel, and that means we shouldn't leave it completely off the table just yet. And there you have it. Scientific time travel in a nutshell. Any more questions?